Now we get into the different types of series, and also we're going to get into the different types of tests that we can use to test for convergence. So the first one that we're going to look at is the geometric series, which is quite popular because, again, we can find the value. If the series does converge, then we can find that value. All right, there's a formula for it. So the first question is, well, what will allow the series to converge? All right, well, we know a geometric series has a common ratio. All right, we're always multiplying by the same term to get to the same value to get to the next term. Okay, and that common ratio is r, and as long as the absolute value of r is less than 1, then that means that the series is going to converge. Right? In other words, if we're multiplying by a half every time, right? 16, 8, 4, 2, 1, so on and so forth, that series will converge to a value, right? Because the common ratio is less than 1. If we're multiplying by 2, right? 1, 2, 4, 8, 16, that series is not going to converge because now r is equal to 2, and obviously 2 is not less than 1. Right? So if the series does converge, we can quickly get the value by taking the first term and dividing it by the quantity of 1 minus the common ratio. And that will get you your value guaranteed every single time. So let's find the sum of some geometric series. Our first example, we see 5 halves plus 5 quarters plus 5 eighths plus 5 sixteenths. All right. So in order to find the series, right, we need the first term, which we have, it's 5 halves, and we have to divide that by 1 minus the common ratio. Now we're not given the common ratio, but we can quickly determine it. What are we multiplying by each time to get to the next term? What's our r? Right? Yeah. You're right, it's a half. Right? 5 halves times a half is 5 quarters. 5 quarters times a half is 5 eighths. Right? So r is equal to a half. Right? And so we have 1 minus a half in our denominator. So what does that leave us with? Well, we've got 5 halves in the numerator. 1 minus a half is 1 half in the denominator. So it looks to me like that will simplify to just 5. Right? And that is what? Answer D. That's our fourth option there on the notes. For our next example, we have 3 plus a 1 plus a third plus a ninth, and we're looking to find the sum of all of those terms. All right. So in doing so, same formula. S is equal to the first term, which is 3, is in our numerator. And then in the denominator, we have 1 minus the common ratio. All right, well, the common ratio, we're always multiplying by 1/3. So we'll have 1 minus a third in the denominator. Right? So simplifying this, we have 3 over 2/3. And if you're dividing by 2/3, that's the same thing as multiplying by what number? 3 halves, good. So this is 3 times 3 halves, or a final total of 9 halves, or 4.5 if you prefer. And last but not least, we actually don't have the terms given to us individually this time. We're given the general term. So this is the situation, and you can identify what r is, and you can identify what the first term is. Go right ahead in that manner. If that's a little bit more difficult for you, then there's nothing wrong with actually writing the first few terms of the actual series. Okay? So we know that n starting with 1. All right? So if n is 1, we have 2 squared over 3 to the first. There's our first term. Right? Then we need our second term. So now n is 2. So that's 2 cubed, right, which we know is 8, over 3 squared, which is 9. Okay. And if we go to our, n now bumps up to 3. So now we have 2 to the 4th, which is 16, over 3 cubed, which is 27. So on and so forth. Okay. Now at least we have our first term. All right, so we know that s is equal to 4/3 divided by 1 minus, and well, what's happening? All right, well, we are multiplying the numerator by 2, multiplying the denominator by 3, and that's happening over and over again, so our common ratio is 2 over 3. All right, so we have 1 minus 2/3. So this is going to leave us with 4/3 over 1/3, which should simplify to 4, which I believe is option C.